Hi everyone, in this video we'll study exponential random variables. An exponential random variable is a continuous random variable. So let us assume that x is an exponential random variable and its PDF or probability density function is given by this form. That is, fx is going to have this form: lambda times e to the power minus lambda x if x is greater than equal to 0 and is going to be 0 if x is less than 0. So x is a continuous random variable with this probability density function. Now x, lambda is the parameter on which x is dependent, or the distribution of x is dependent. Okay. Now, how do we calculate the cumulative density function, or CDF, of x? So that is given by f, capital F, and you can calculate it this way. Basically, you have to integrate between 0 to a. So fa, integrate between 0 to a. Essentially, what you have to do is integrate fx dx, and here fx is lambda e to the power minus lambda x dx. Now this integration is fairly simple, and that will evaluate to e to the power minus lambda a for a greater than 0. Okay, of course a has to be greater than 0. So the small fx here, that's the PDF, probability density function, and the capital F is the CDF, or the cumulative density function, cumulative distribution as well. Okay, now that we have studied this, what we are going to do is we are going to look at the expectation of an exponential random variable. Okay, so let's try to find its expectation. So expectation of x is going to be given by this form. That is, we are going to integrate between 0 to infinity, because x is a continuous random variable and it is defined for all values of x greater than 0. For x less than 0, it is 0. So it doesn't make any sense to integrate between negative infinity to infinity. So we integrate between 0 and infinity. It's x fx dx, and we are going to substitute fx. So it's going to integrate between 0 to infinity, x lambda e to the power minus lambda x dx. And let's carry out this integration. To carry out this integration, what we will have is this one, that is minus x e to the power minus lambda x, and we have to substitute 0 and infinity. You can do this integration by parts. It's pretty easy. That's what we have done here, integration by parts. And we'll have 0 to infinity e to the power minus lambda x dx. Okay. Now, if you do this, this is going to evaluate, the first part is going to evaluate to 0. That is easy because you can substitute the value of 0 and infinity, you'll get 0 there. And the second part is going to evaluate to e to the power of minus lambda x divided by lambda. And this integration, we have to put values between 0 and infinity. Now doing this, if you put a value of infinity, so this is 0, so let's just see what happens. If you put the value of infinity, it's going to e to the power minus lambda infinity divided by infinity. Okay, minus e to the power of minus 0 by lambda. Now e to the power of minus lambda infinity, that will evaluate to 0. Okay, so it's going to be minus 0 minus 1 by lambda, which will evaluate to 1 by lambda. Therefore, expectation of the exponential random variable is going to evaluate to 1 over lambda. So Similarly, using this approach, you can also find out the variance of this random variable. Okay, so what did we study here? We studied what is the PDF of an exponential random variable, which is right here. We studied what is the CDF and how to calculate the CDF. And then finally, we looked at how to find the expectation of an exponential random variable. With this, I'll complete this video. Thank you for watching.